Micro-robots swimming through our bodies? AI needs a good night's rest? What does the future of data storage look like? And finally, time to get registered for Hacktoberfest. Stick around to find out more in this episode of News Bytes. Hello and welcome to Advanced Ingenuity Labs, your insight into technology. I'm your host, Aisha Sharif, and this is News Bytes, where we cover innovative developments in the latest technologies. A recent Cornell University collaboration has created microscopic robots that can move with standard electronic signals. The research team which made this breakthrough is comprised of Itai Cohen, Professor of Physics, Paul McEwen, the John A. Newman Professor of Physical Science, and their former postdoctoral researcher, Mark Miskin, who is now an assistant professor at the University of Pennsylvania. The robots, roughly the size of a single-celled paramecium, provide a template for building even more complex versions that utilize silicone-based intelligence. They can easily be mass-produced and may someday travel through human tissue and blood. The micro-robots look fairly simple in their design. They're only about 5 microns thick, 40 microns wide, and between 40 and 70 microns long. Each robot consists of a simple circuit made from silicone photovoltaics, which essentially functions as the torso and brain, and 4 electrochemical actuators, which function as legs. The legs are made of strips of platinum with a layer of inert titanium on one side and polymer panels on the other side. The researchers control the robots by flashing laser pulses at the different photovoltaics, each of which charges up a separate set of legs. By toggling the laser back and forth between the front and back photovoltaics, the robot walks. The robots are certainly high-tech. However, they operate with low voltage, just 200 millivolts, and low power, only 10 nanowatts. Yet they're strong and robust for their size and are also relatively easy to make using standard microchip manufacturing procedures. Itai Cohen, lead researcher on the study, says while these robots are primitive in their function, they're not very fast, they don't have a lot of computational capability, the innovations that we made to make them compatible with standard microchip fabrication open the door to making these microscopic robots smart, fast, and mass-producible. This really is just the first shot across the bow that, hey, we can do electronic integration on a tiny robot. The researchers are investigating new ways to improve the capabilities of these robots with more complicated electronics and onboard computation. Improvements could lead to these robots being used in swarms by crawling through and restructuring materials, suturing blood vessels, or being dispatched to probe large sections of the human brain. They eventually could even perform a variety of additional tasks, like delivering drugs to specific tissues or clearing cholesterol out of arteries. Soon, a troop of micro-robots may be swimming, crawling, flip-flopping, or squeezing through our bodies. Miskin, the study's lead author, states controlling a tiny robot is maybe as close as you can come to shrinking yourself down. I think machines like these are going to take us into all kinds of amazing worlds that are too small to see. We all know how refreshed and clear-minded we feel after a good night's sleep. And it looks like that may also apply to our AI friends as well. Researchers from Los Alamos National Laboratory have found that the artificial intelligence they designed to function as a human may need periods of sleep, just like their human brain counterparts. The discovery came about as the research team were developing neural networks, which closely approximates how humans and animals learn to see. Neural networks are made up of artificial neurons which signal to each other, like neurons in a brain. Connections that are repeatedly used are reinforced over time, which allow the neural networks to learn on their own. The research team at Los Alamos found that after long periods of unsupervised learning, as their AI was attempting to classify objects using their existing dictionary definitions without having any prior examples for comparison, would become unstable. This method of learning turned out to be more mentally taxing for the neural networks than expected. As the researchers struggled to stabilize the AI, they experimented with various types of noise, similar to the static heard between radio stations. The best results came when they used waves of Gaussian noise. The researchers hypothesized that the noise mimics the input received by biological brains during slow-wave sleep. Therefore, as a last-ditch effort, they decided to expose the neural networks to artificial sleep. The results suggest that when exposed to a state that is similar to what a human brain experiences during sleep, it benefits the neural networks. The group's next goal is to implement their algorithm on Intel's Loihi neuromorphic chip, which emulates the neural structure of the human brain. This chip includes 130,000 neurons, which have been optimized for spiking neural networks, making the hardware suitable for sensation and perception tasks. They hope that by allowing Loihi to sleep from time to time, it'll be able to process the information from a silicone retina camera in real time without the loss of stability. As we use our computers, smartphones, and other similar electronic devices, an extensive amount of electronic data is constantly being generated. It's estimated that by 2025, the amount of electronic data worldwide will be 175 zettabytes. Where is all that data being stored? Currently, this massive amount of information exists across a variety of platforms and in many mediums. But this is changing as new data storage solutions are becoming available. Data storage capacities are limited by the size of the storage device. Cloud storage has quickly become the preferred method of data storage. With cloud storage, your limit depends on the price you're willing to pay to store your data. While it seems that cloud storage is limitless, it's not. All that data still has to be physically stored. Scientists are diligently working to develop data storage options that can contain this exponentially growing amount of information. Just as technology has rapidly transformed over the past several decades, so too will data storage. With that in mind, here are a few emerging technologies and trends for the future of data storage. Helium drives are large capacity drives that offer more storage per square centimeter, run cooler than air-filled drives, and use less power to spin the disks. Helium data storage devices are already available to consumers, but the price tag is high. However, the decreased risk of data loss just might be worth it. Shingled magnetic recording, or SMR drives, are another relatively new storage drive that's also available for consumers. SMR introduces a new way for hard drives to record data. Hard drives with this technology push tracks closer together with higher areal densities. Data is stacked like shingles on a roof, increasing storage capacity in the same amount of space. This data writing style doesn't even require new equipment, keeping the cost low and making the newer SMR technology affordable. Data storage in space is currently being developed by a growing number of businesses with the use of satellites as an alternative to traditional data centers. The advantages of storing data in space include improved cybersecurity and the potential to store much larger volumes of data. Just this last April, IBM announced that they plan to move Watson, their artificial intelligence system, to space on the Cloud Constellation Corporation's satellites. Another frontrunner in the data storage race is DNA. Back in 2012, researchers at Harvard University successfully encoded human DNA with digital information. Since then, scientists are getting closer to making DNA storage an affordable and accessible option. DNA can hold 2.2 petabytes of data per gram. That's unparalleled in the terms of storage capacity. In fact, the whole world's data could easily fit into a single teaspoon of DNA. Also, DNA holds data forever. No other data storage option can even come close to its longevity. Naturally, there are a few drawbacks to using DNA for data storage. First, writing to and reading from DNA is a lengthy and very expensive process. Scientists are working with artificial DNA in order to make it more readily available and less expensive solution. Quantum memory and holograms are additional data storage options that are presently being researched. While the next widely adoptable data storage solution is unknown at this time, what's evident is that the amount of data in the world will only continue to grow. I can't wait to see where my data will be stored in the future. What options do you see as the most likely candidate for the future of data storage? Let me know in the comments. Let's end this episode with an announcement for the upcoming Hacktoberfest. Hacktoberfest is a month-long virtual festival to celebrate open source contributions and is presented by DigitalOcean and Dev. Hacktoberfest's simple objective is to support open source and earn a limited edition t-shirt. It really is more than just limited edition t-shirts or stickers. It's about supporting and celebrating the open source community and giving back. If you've never contributed to open source before, this is the perfect time to get started. Hacktoberfest is open to everyone, whether you're a developer, a student learning to code, event host, or a company of any size. You can help drive the growth of open source and make positive contributions to an ever-growing community. All backgrounds and skill levels are welcomed and encouraged to complete the challenge. I'll leave a link in the description with more information regarding Hacktoberfest 2020. What will you contribute? Let me know in the comments. That's it for this episode of News Bytes. If you enjoyed this video and want more, leave me a comment and consider liking and subscribing. See you next time.